All right, so hopefully you have all looked through the videos from chapter one and you were able to start the homework in chapter one after you've registered for my math lab. Also know that there's a like a pre-quiz for each chapter to kind of see like what it is that you already know. And then as you start to progress through the homework, it just allows me to kind of see like what you already know going into the course and what you were able to learn through the videos and through practice. It will not allow you to do the um, the homework until you have taken those quizzes because it is a prerequisite. So make sure that you are taking that seriously. All right. So with that said, let's go through and start chapter two. Okie dokie. So linear equations in two variables. So that's what we're going to be talking about here in chapter two. Interpret line graphs, plot ordered pairs, graph lines, x and y intercepts, things like that. Most of you have already seen this material, whether you've taken it in, algebra back in the day, or you saw it when you were in the Emporium. Okay. So let's see what's going on here. There we go. So hopefully this is now ready to rock and roll. All right, so why are line graphs important? Obviously, there's a lot of things that are linear in nature. Um, you know, when you get charged a certain amount of money per hour or something like that. When you work hourly, you are being paid an hourly rate. So for every hour that you work, they're going to pay you whatever your hourly rate is. So that's a linear graph until you get to 40 hours, and then you're required to be paid overtime for more than 40 hours. All right, so you're going to hear me say the Cartesian plane. It's the XY plane, the rectangular coordinate system. No matter how you slice it, it is going to be an ordered pair. Ordered is important here. It needs to be X first and then Y. Okay, and if you ever forget, it's in alphabetical order. So that's one nice way of remembering it. This is X comes before Y in the alphabet, so X comes before Y in this ordered pair as well. All right, and that's called its components. We generally plot those points on the Cartesian plane, and we can make sure that we're putting the point on that Cartesian plane. All right, so there are four regions of the graph. They're called quadrants. All right, so you have quadrant one, where everything is positive. Your X and Y are both positive. Quadrant two, heading in a counterclockwise direction. Your X coordinate is negative and your Y coordinate is positive because you're still above the X axis. All the points up here are above the X axis. They're all positive values, okay? But you're to the left of the Y axis, which is why your value is going to be negative for your X. Down here in the third quadrant, everything is negative. X and Y are both negative. And here in the fourth and final quadrant, you have your X value is positive and your Y value is negative because your Y value, again, is below the X axis. So your Y value will be negative there, okay? And notice that you have the point, again, 3, 2. The way that you graph that is you kind of start at the origin. You go over to 3 for the X and then up to 2. Then you place your point. A lot of students say, all right, 3, 2. They go 3 and then 2. No, it's only 1 point, right? So it's going to be over to 3, up to 2, and then you place your points, okay? So let's go ahead and complete the ordered pair. So we have an equation in two variables. So we have 3x minus 4y equals 12. And they're saying to us, well, if you substitute 0 in for x, you should be able to figure out what y is. So that means if you take 0 in for x, again, take x out, put 0 in, minus 4y is equal to 12. This, of course, is going to go away, and you're left with negative 4y is equal to 12. And, of course, we can solve this very easily, and we get y is equal to negative 3. So our y value here is negative 3. when you substitute 0 for x. And then I think what they're going to want us to do is to solve the rest of these, so we might as well do that here. This say substitute 0 for y this time, so you can get 3x minus 4 times 0 is equal to 12. So 3x is equal to 12 because this cancels out, and then x is equal to 4. So when y is 0, your x value is 4. And then we'll substitute this one as well. So on to the next one, 3x minus 4, substitute in negative 2 is equal to 12. 3x plus 8 is equal to 12. 3x is equal to 4. Again, I'm going to start sort of skipping these trivial steps because this is now covered in chapter 1 and we're out of chapter 1. So I really am not going to be showing these types of steps anymore. And then we're going to get x is equal to 4 thirds. So 4 thirds is our x. And then last but not least, we'll substitute negative 6 for x. So this is going to be 3 times negative 6 minus 4y is equal to 12. This is negative 18 minus 4y is equal to 12. You're going to get negative 4y is equal to 30 by adding 18 to both sides. And then last but not least, you get y is equal to negative 15 halves, simplifying the fraction because you would get 30 over negative 4. And of course, you can't leave it like that. It's an unsimplified fraction. So we simplify the fraction to get negative 15 over 2. And it doesn't matter where the negative goes, so long as you only have 1. There's no difference between positive 15 over negative 2 is the same thing as negative 15 over 2, which is the same thing as having the negative just kind of like out front and saying, well, but one of these is negative, and that's why there's just one of them there. Okay. All right, so the graph and equation is the set of ordered pairs of points corresponding to all the ordered pairs that satisfy the equation. It gives you the picture of the equation. So a linear equation in 2 variables has a standard form. It is ax plus by equals c. This is standard form of a linear equation in 2 variables. Ax plus by is equal to c. Okay. A straight line is determined if any 2 different points on a line are known. Therefore, finding 2 different points is enough to graph a line. So the minimum that you need to be able to graph a line is 2 points. You graph 1 point, you graph another point, and then you connect dots, and you will be able to figure out what your shape of your line is, okay? Or what direction it's heading in. The line has no shape, okay? So when graphing the equation of a line, we're going to find the intercept. So essentially, I use this. I call it an intercept table. So you just create your XY table. You put 0 here and a 0 here. And you find the 2 points that you need to graph your line. So I use it, again, an intercept table. 0 is my favorite number to substitute. It's very convenient here in finding the intercepts because when x is 0, your numerical value for y will give you the y intercept, and this one will give you the x intercept. So find the x and y intercepts for this equation here, and we're then going to graph it. So again, I'm going to use this intercept table to figure out what these intercepts are. So again, substitute 0 in for x. So we have 2 times 0 minus y is equal to 4. And that's going to be negative, I keep doing a 4 here, a negative y is equal to 4, which means y is going to be equal to negative 4 because you've got to divide by negative 1, divide by negative 1. So your y-intercept is at negative 4. So I'm going to go ahead and plot that point right here. So again, 0, negative 4, x is 0, y is negative 4. Boom, there's your first point. And now let's go ahead and figure out where our second point is. So this time we're going to substitute 0 in for y. So 2x minus 0 is equal to 4. So 2x is equal to 4. X is equal to 2. So when your y value is 0, so you're not going up or down at all, you're actually staying right here on this x-axis. And where on that x-axis is going to be at positive 2. So now we have our 2 points, and that is enough for us to be able to graph this line. Do our best. It's not as easy with these digital pens, and there we go. We have graphed this line effectively. All right, so let's go ahead and do this one now. This one, if we try to use an intercept table, something interesting is going to happen. I'm struggling with my Y's today. 0 and 0. So we try to use the intercept table. Because I have a 0 here for C, we end up getting the same points. So I'll show you what to do when we kind of cross that bridge. So we get 3 times 0 minus y is equal to 0. And then negative y is equal to 0, which means y is also equal to 0. So there it is. So there's your point 0, 0, which means your line is crossing at the origin. Your x and y intercepts are going to be exactly the same. There's no point in substituting 0 in for y because you already have it right here. You already know what its corresponding x value is going to be. It's going to be 0. So what I usually have students do at this point is when you get the same x and y intercepts, meaning it's crossing at the origin 0, 0, pick some other points, some other value for x besides 0. Again, it doesn't matter what you do. You want to be somewhere around the origin so that way you can actually effectively graph it. So I'll pick 1. That's pretty close to the origin, and it's my second favorite number to substitute. So I'm going to substitute 1 for x and see what happens. So 3 times 1 minus y is equal to 0. 3 minus y is equal to 0. Negative y is equal to negative 3 by subtracting 3 to both sides. Y is equal to positive 3. So when x is 1, y is 3, and that is where we're going to get our second point. So when x is 1, y is 3, boom, there's our second point. We have enough now to connect our dots, put our arrows in, and move on with our lives. Cool. So these are kind of intriguing for a lot of students. These situations are unique because number one, you're supposed to be graphing these with x's and y's, right? But this equation here does not have the x. The x is completely gone. So this is one of our special cases, and when y is equal to some number, okay? So if this is the scenario that you have where one of your variables is missing, in this case, the x is missing. When y is equal to a number, this is going to represent a horizontal line at that number, all right? So it's a horizontal line at the number, okay? So in this case, you have y is equal to 3. So y is equal to 3 is right here. And we are going to get a horizontal line at that number. Do the best that you can to do that horizontal line. And the reason for this is every single point that's on this line, every single one of these points, even the ones that are over here, you know, in the no man's land, but every single point on this line has a y value that is 3. This one is 0, 3. This one over here is 2, 3. This one over here is at negative 3, 3. So no matter what, the y value is equal to 3. Doesn't matter what the x is. X is not even over here at all. It's the y value that's going to be 3, and all of these points have a y value of 3, okay? So that means that when you have the other situation where the y is missing, okay, so y is missing in this case, and you have some situation where it's x is equal to, again, some number, this one is going to be a vertical line at the number, okay? So this situation is pretty much the exact opposite of the other one where it was y equals a number, that was a horizontal line. X equals a number is going to be a vertical line. So this, once we solve for x, is going to be x is equal to negative 2, and that is a vertical line at that number. Okay, so vertical line at that number. And again, for the same reason as the y equation, every single one of these x values that's on this line has a value of -2. This one over here is -2 comma 3. That one over there is going to be -2 comma -2. So all of the x values, -2 comma 0. These x values that are on this line are going to be -2, which is what this says. Okay? So just make sure that you're studying these special cases. Students freak out and they panic when they're taking tests. They forget what happens with those. So just try to commit it to your memory as much as you can. They're special cases because they don't have x and y. They are missing one of the variables, and it's because the coefficient, if you remember, we had this ax plus by is equal to c, the standard form, and it said that both a and b cannot both be 0. When you go back to that, it says it can't both be 0. One of them is. In this case, your b is 0, and that's why the y is gone, because 0 times y is going to be 0. It won't be there at all. It's going to get rid of that variable. So that's the reason why your y value is gone in this equation. And the exact opposite would be when the x is gone, your a value is 0. So here's the midpoint formula. So this one's pretty much just taking an average of the x values and an average of the y values. We talked about it at the end of chapter 1 that to take an average, you add up all the numbers and then divide by the number of numbers. Well, over here, you have 2 x values, you're dividing by 2. You have 2 y values, you divide it by 2, and you get your midpoint, which is the point that is in the middle, okay? So let's go ahead and do this. So to figure out what the midpoint is, again, we are going to add up our x values and then divide by 2, and then we're going to add up our y values and divide by 2. So this is going to be -3/2. That's your x value. And this one is going to be 6. 8 plus 4 is 12, divided by 2 is 6. So there's your midpoint. Very quick, very easy, especially if you're staring at the formula. It's not rocket science to be able to figure out. Okay? 2.2, we're going to talk about the slope of a line. So we have graphed a couple of lines in the previous section, and now we're going to talk about the slope of these lines. And when you're dealing with slope, there's a slope formula. It's a lot of alphabet soup. Most students have a difficult time remembering if it's minus or plus, but hopefully you guys don't have that same issue. So we know slope is a rise over a run. It is your rate of change from your vertical change to the horizontal change, okay? I believe that this phrase here, slope is a rise over run, is sort of an incomplete phrase. I believe that it should be slope is a rise over run from one point to another point, because you need this first point to be able to use your slope. If you don't have a starting point, then you have nothing to do with that slope. You need a point to start at, then you use your rise over run to figure out where your second point is. And that's important because you only need 2 points to graph a line. So once you have your 2 points, you can connect your dots and move on. You will have your graph. Okay, so here's the slope formula. It's m is equal to y2 minus y1 over x2 minus x1. These numbers here are just subscripts. They're just telling you that these are the x and y values from the first point, and these are the x and y values from the second point. It doesn't matter which one you make the first point or the second point. That's not going to change your answer. You just need to be consistent. Okay, notice that these 2's line up over here and these 1's line up over there. That has to be the case. If you start flopping them, then the slope of your line is going to be the wrong sign. Okay, so let's find the slope of the line passing through these points. So usually what I do is I start by labeling these. So I'll say you're my first point, you are my second point, so there and there. And then I'm going to just substitute into the slope formula. So y2 minus y1 over x2 minus x1. So notice that these minus live in the formula, okay? And you're substituting a -6 in here. So what's going to happen as a result is you're going to add those denominators. So this will be -14 in the numerator, and that's going to be +9 in the denominator. There is your slope. So you're going to go down 14 to the right 9 to be able to figure out, what your next point is. All right. So if you started here to get there, again, you go down 14 and then to the right 9. Okay. So let's go ahead and find the slope of this line. So what they want us to do is they want us to use the slope formula to find this problem. All right. To be able to find the slope. We're not going to do that. I'm going to show you a quicker, faster, better way to find the slope, okay? So we are in standard form here. So there it is, okay? AX plus BY equals C. So if you're in standard form, to find your slope, you take the opposite of whatever your A is and then divide it by whatever your B is. So that is the fastest, most efficient way to find your slope if you're in standard form. Another way would be to turn this into slope intercept form, y equals mx plus b. You don't know about that yet in this class. If you know about it already, that's great. You're probably going to be able to figure out the slope already. But if you're in standard form, the fastest way to find the slope is to take the opposite of A and divide it by whatever the B is. So to find our slope, we're going to take, again, the opposite of whatever our A is, so -3, and then divide it by whatever the B is, which is -4. So our slope here is 3/4. The way that they wanted us to do this was to find the points. We needed to, keep doing this, X and Y. They wanted us to figure out what the intercepts are, because that's one of our strategies that we have right now. When you substitute in 0 here, you get -3. When you substitute 0 for Y, you get +4. And now you have 2 points. You can use the y2 minus y1 over x2 minus x1. Super tedious. I would not advise to do that. You certainly can if you wanted to. I am going to go ahead and just use this gem right here, which is the opposite of A divided by B. Opposite of A divided by whatever your B is, if you're in standard form. All right, so let's find the slope of this line here. So the first thing we want to do is get y by itself. We'll notice that this is one of our special cases because our x is not here, and we have y is equal to -3. And we also learned in the previous section that this is going to lead to a horizontal line. With a slope, I'm going to just show you this now, your slope of a horizontal line is 0 all the time, every single time. Because remember, slope is a rise over a run. And if we had this vertical line here, horizontal line at -3, how much is this horizontal line rising? Yeah, it's not, right? So there has a 0 rise and plenty of run. If you pick this point right here, it's got a run of 1. It's going over by 1 unit, and 0 over 1 is 0. So that is why the slope of these horizontal lines will always be 0, okay? And on the flip side, we have, again, our special case here. This one's going to be our vertical line at whatever the number is. So our vertical line at -6. And this situation is going to have a slope that is called undefined. Okay? So this slope is undefined. And the reason why is because this line has no run. So remember, slope is a rise over a run. And the run here is 0. It's not moving from left to right from one point to the next. This is just going straight up and down. It's not moving left and right. So this has a rise of 1, 2, 3, and it has no run. And you learned a long time ago that if you have 0 in the denominator, this fraction is called undefined. defined. You cannot divide by 0. So that is why the slope of this special case line, this vertical line, is undefined. Okay. The equation of the form y equals b always intersects the y-axis at the point 0b. So this right here is representing the y-intercept, and a line with this equation is horizontal and has slope 0. The equation of the form x equals a number always intersects the x-axis at some point a0, and the line with this equation is vertical and has an undefined slope, which is exactly what we just talked about. Okay, so let us find the slope of this graph. And again, I'm going to take the shortcut to go ahead and say, well, my slope here is going to be the opposite of a divided by b. So my slope here very quickly is -3/4. Super fast, super easy. If you were to try and do this the other way by finding your x and y intercepts, you would still probably be doing that, and we are done with this equation. Okay, so the graph passing through the line, this point right here, -3, -2, has a slope of 1/2. Again, slope is m is equal to 1/2, which is a rise over a run. So what we do, and remember, slope is a rise over run from one point, bing, 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 one point to another point. So I'm going to graph this one. It's going to be in the third quadrant since both of these coordinates are negative. Components are negative. So I'm going to graph that right there. So -3, -2, boom. And then from here, I'm going to use my slope, which is 1/2. So that means from that point, you go up 1 to the right 2. So go back to the point that you graphed. Again, remember, this is your starting point. Then you go up 1 over 2, and you will get your next point. You can do it again if you wanted to, up 1 over 2, up 1 over 2, and you can see that all of these points are on the exact same line. So we just connect the dots, and we're done. Okay. So this is a nice little slide here that talks about positive slopes and negative slopes and zero slopes and undefined slopes. One of the things that you should be thinking about is before you graph these equations, if you know what the slope is, then you will know what your line should look like, which direction it should be heading in. If you have a positive slope, but your line looks like this, that's a big problem. The negative slopes look like this. Positive slopes look like that. They go up from left to right, where negative slopes go down from left to right. So you really want to be on the lookout for these things. So that way you are ensuring yourself that you're going to get the right answer, more often than not. Because I know that if you have a positive slope and your graph looks like this, you've got no chance. You are definitely going to get that problem wrong. In my math lab, where you're going to be taking your tests, is pretty ruthless. They're not going to give you partial credit because you got the right idea behind it. They're going to say, nope, that's not the right graph. It's wrong. Okay. So two non-vertical lines with the same slope are parallel. Most students know that parallel lines never intersect. Okay, so parallel lines never intersect. They have the same slope, the same rise over run, which is why they are not going to intersect at any points. Okay, so we are going to figure out if these are parallel or not. Right. So the way that we do that is to figure out what their slopes are. So I'm going to figure out what the slope is of these first two. So 5 minus 2 over 3 minus -1. And that's going to give me 3 over 4 for the first slope. So this has a slope from this point to that one of 3/4. So now I'm just going to do the same thing here. So m is equal to 10 minus 7 over 8 minus 4, and that's equal to 3/4 again. So since our slopes are exactly the same, these are parallel, okay? They are parallel. And the symbol that we use symbolically, we say that they are parallel. So this is just like two lines that look like they're parallel. So if you don't have to write out the word parallel, if you don't want to. Okay? Perpendicular lines, they intersect, unlike parallel lines who don't intersect. Perpendicular lines, they also have a special relationship with their slopes. They are opposite reciprocals to one another. They say negative reciprocals. I like to use the word opposite because it just makes a little bit more sense to me. But yeah, opposite reciprocals. And it says their product is -1. So you could always check your answer to make sure that that's legit. With the one exception being that a line that has a zero slope, aka a horizontal line, has a zero slope, will be perpendicular with a line that has a vertical slope or an undefined slope. Okay, and perpendicular means they intersect and create a 90-degree angle. Okay, I lost my pointer here. Let's see. Oops. Not what I want. Sorry, bear with me here. There she is. She's back. All right, so let's figure out, are the lines with these equations perpendicular? Okay, so I'm going to use my shortcut to figure out what these slopes are. So m is equal to the opposite of a over b, and then the other one is going to be the opposite of a over b, which is going to give you 5/3. So these are, in fact, opposites. One's negative and one's positive, and they are reciprocals. 3/5 and 5/3. They are reciprocals. So these are perpendicular. Because, and again, you could always check your answer by doing the product. They said the product should be equal to -1. So let's just check that real quick to make sure that it is. So this is -15 over +15, which is -1. So yes, it does check out. All right, so these are opposite reciprocals. All right, one's positive, one's negative, and the fractions are flipped. Okay, so let's figure out if these are parallel, perpendicular, or neither. So again, shortcut to find the slope, opposite over whatever the b is. So our slope here is 4/1. And then the other one is going to be the opposite over whatever the b is. And this is going to be +1/4. So this one makes us feel like these are going to be perpendicular because they're reciprocals, but they're the same sign. They're not opposites. So these are neither. Remember, in order to be parallel, they have to be exactly the same. These are not exactly the same. This is 4/1 versus 1/4. And in order to be perpendicular, they have to be opposite reciprocals. These are not opposite reciprocals, so therefore it's going to be neither. These lines will intersect because obviously if they didn't intersect, they would be parallel, but they don't create that special intersection of a 90-degree. All right, so average rate of change. So this is more for like word problems and things like that. Obviously, you can see here that these are digital cable TV customers. You know, if the trend continued from 2007 to 2012, which is a 5-year span here, then you could also, 6-year span, you can kind of extrapolate that out for another 6 years if you're trying to predict the future, or even, you know, if you anticipate that it's going to be linear going forward, you could even try to figure out what it's going to be like from 30 years from now. Okay. All right, 2.3, and we're getting pretty close to being done with this video. Again, I'm trying not to go too fast, but I know that you also have the ability to, you know, pause and rewind and go back to it to make sure that, you know, you really understand the material, versus if this were just a lecture, we move on and hopefully you caught it. And if you didn't, it's sort of like you've got to do some research on your own to figure out what happened. Okay. So writing equations of lines. So let's go. So again, this is just a reminder, slope is a rise over run from one point to another point, and there's going to be some forms that we're going to talk about in this section. So one of them will be something that's called slope-intercept form. So slope-intercept form of a linear equation deals with two things. It deals with your slope, whatever your coefficient of x is your slope, and it deals with the y-intercept. So what's nice about this form is that if you recognize that you have it, you can very quickly graph your y-intercept because you know that that's going to be on the y-axis, and then you're going to be able to use your slope, your rise over run, to figure out where your second point is, because you only need 2 points to graph a line. So why not use the y-intercept if they're going to give it to you, and then use the slope that's also given to you to come up with your second point. Okay, so y equals mx plus b is slope-intercept form. And most students remember that from algebra. They may not remember what to do with it, but they remember vaguely this y equals mx plus b from their previous algebra classes in the past. Okay. So again, this is just telling you what I already told you, that your m here, your coefficient of x, is your slope. That's your rise over run. And your b is your y-intercept. Remember, you cannot use this guy, the slope, until you do this one. So this is first, b for begin, and then this is second. You cannot use the slope without first graphing the y-intercept. All right, so let's write an equation of a line with slope 2 and a y-intercept of 0, -3. So we know that an equation that we could use is y equals mx plus b. And if they're going to give us the slope of 2, I'm going to put that there. And they're going to give us the y-intercept of -3. I'm going to put that there. And now I have an equation in slope-intercept form with this information. So let's graph this line using slope and the y-intercept. So what we can do is put this in slope-intercept form by doing this. So solving for y. So we're going back to what we did at the beginning of chapter 1, is getting y by itself. So if I had x plus 2y equals -4, I would subtract x to both sides, and that gives you 2y equals -1x minus 4, and then divide everything by 2. You get y equals -1/2 x minus 2. There's your slope-intercept form. So I'm going to graph my y-intercept first because that's where I'm supposed to start. This slope is pointless. It's useless without a starting point. And then from here, since my slope is -1/2, I'm going to go down 1 to the right 2. So from this point, down 1 to the right 2. And this is great for us because remember, I have a negative slope. And we're anticipating our line to go down from left to right because I have a negative slope. So I'll be able to connect my dots. You could also go up and to the left if you wanted to. So if you made this 1 over -2, you would go up 1 and to the left 2. So up 1 to the left 2, and you'll see that, bam, you're still in the exact same line. So it does not change what the line does. It just changes which point you're using to connect the dots. And this is like the forgotten form. It's point slope form. Most students don't use this one because they don't really remember it. It's got a lot more components to it. They remember standard form because it's standard, and they remember the slope-intercept form, that y equals mx plus b. It's just a lot easier to remember. But here it is, and it's a very helpful form when you have a slope, when they gave you a slope and they gave you a point. You can create an equation from that situation using point slope form. Okay, so just in the interest of making our lives a little bit easier, what I'm going to do is I'm going to change this from 3 to 5. Just to make our lives a little bit easier. I'm tired of dealing with these fractions. This is the summer. Let's take it easy. So what I'm going to do is I'm going to use the point slope form. So this is my x1 and my y1. There's my point, and here's my slope. So y minus my y1, so minus -4, is equal to my slope first, 2/5 x minus your x1, which is 5. So let's clean it up a little bit. So let's do y plus 4 equals 2/5 x minus 5. And this right here is sufficient. We have written an equation in point slope form. Most of the time, you don't want to leave your equation like this. Number one, it's not simplified because there's still parentheses here. So what do we have to do? We've got to get rid of parentheses, and most students will just get this solved for y. They'll put it into slope-intercept form. So they're going to distribute this into the x and the 5, and hopefully you'll see why I changed it to 5 instead of 3. We've got y plus 4 equals 2/5 x minus 2. Again, the 5's cancel. You're left with this minus 2. And then we can always subtract 4 to both sides if you wanted to as well. And that's going to give us y equals 2/5 x minus 6. Okay, so that is an equation in slope-intercept form with this information. Okay, so let's do one more of these, and that'll be it for this video. All right, so let's do this. So let's find the slope first. So let's start with that. So we're going to do 4 minus 6 over 1 minus negative 2. Again, using your y2 minus y1 over x2 minus x1. And that will give you negative 2. And this will give you 3. Okay, so your slope is negative 2/3. And then if you're doing the exact same thing that we just did using the slope point slope form, you're going to take this slope and substitute it in, and then also you're going to use one of these points. It doesn't matter which one, you just have to pick one. So let's go ahead and use the point slope form. So I'm going to pick this one. There's no negatives there. It doesn't matter which one you pick, you'll get the same answer either way. So y minus 4 is equal to negative 2/3 x minus 1. And what I'm going to do, if this has to be in standard form, is I'm going to get rid of this fraction right away because I don't want to have to distribute this fraction and then play with that. So I'm going to multiply everything by the LCD, which is 3. So that's going to give me 3y minus 12 is equal to negative 2 parentheses x minus 1. And now I'm going to distribute the negative 2 in. You get 3y minus 12 is equal to negative 2x plus 2. And standard form, your x and y are on the same side of the equation, and your number, your constant, is over on the other side. So we're going to do that now. So we're going to get 2x plus 3y, adding 2x to both sides. And I'm also going to add 12 to both sides to get 14. Again, adding 12 to both sides, adding 2x to both sides, and we are very happily in standard form. So hopefully you are getting pretty situated with the course. You've registered for my math lab, and you're feeling comfortable with the material that you've seen so far. And I am going to send you the link for the Blackboard Collaborate meetings. I don't anticipate those class meetings running the full 4 hours and 20 minutes that we're scheduled for, or 10 minutes. They are going to run to answer questions that you have on the lecture notes. So please watch the videos, try the homework, do your best with those. And if you have questions, you can always ask those during the Blackboard Collaborate meetings. Right? So thanks very much for listening.